everyone, welcome to the UTA Planetarium's another live stream. My name is Levent Gurdemir. I am UTA astrophysicist and director of the Planetarium. And here today, Jim Bader, our coordinator, program coordinator, is with us. And he will be helping us with the live stream. And today, we are covering the Solar System Tour Part 3, and that is about the gas giant planets in the solar system, or they are also known as Jovian planets. If you remember, we started a couple of weeks ago and we covered the Sun and Mercury system in the first episode, and the second episode was primarily focused on Venus, Earth, Mars, and the asteroid belt. And we left that part of the solar system open, which is the gas giant planets. So we are going beyond the asteroid belt today, and we'll start with Jupiter and Saturn and Uranus and Neptune. So let's take a look at that part of the solar system. And when we do that, we see different kinds of planets. If you remember from the last week's video live stream, the Mars, Earth, Venus, and Mercury, they all had a crust that even some NASA and European Space Agency landers landed on. So they are landable planets. But in this part of the solar system, we are looking at a different kinds of planets, and they are mainly gas. So that's why we call them gas giants. Every gas giant planets thought to be actually have a very solid rocky core inside them. We don't know how big they are, but we are mostly looking at their giant spherical gases. So we don't see that inner core. We don't know how small it is, but it is pretty small in the planets, inside of the interior of the planets. So we call them gas giants. They are also called Jovian planets. So what that Jovian means, Jove is actually the other name of Jupiter. And the Jovian means Jupiter-like planets. Start with the Jupiter. It is the largest planet of the solar system. Jupiter is 1,000 times less massive than the Sun, but it still weighs 2.5 times even all other planets combined. So it's a very massive planet. It is the Jupiter gases are primarily hydrogen and helium, and it is the fastest rotating planet in the solar system. It takes about only 10 hours for Jupiter to rotate around its axis, so that's pretty fast. It is 24 hours if we compare it with Earth. And the Jupiter revolves around the Sun every 12 years. That's the result of Kepler law. There is nothing out of ordinary here. And when we look at Jupiter, as you are looking at on the screen right now, Jupiter has these band features on its surface. And each band region is actually, there are storms, and especially on the boundary regions, there's a lot of turbulences going on. And speaking of storms, one of the greatest, the storm region on the surface of Jupiter is the Great Red Spot. So we need to rotate the Jupiter around a little bit to see it. But that red storm, the red giant storm, is a storm region that is on Jupiter going on at least from since the 17th century. Well, we don't have any observation of Jupiter in detail before the 17th century, so we can say it's been there at least since 17th century. You can actually kind of see it right now. It's in the image. Oh, it's coming right here. There's a giant storm region that takes even several Earths inside of it, and this is continuously going on for centuries. And Jupiter is also known as a failed star. So if Jupiter had enough mass, Jupiter could actually fuse hydrogen and then could become a star, and most like other stars, our sun would have a companion star around it. So it would be a binary star system. But because the Jupiter is a failed star, it doesn't have enough mass to fuse hydrogen, so we call it failed star. Well, the difference is actually a lot, because if Jupiter was not slightly more massive, it needed to be massive 75 more times to fuse mass. So it is not actually close to being star. But when we look at Jupiter in detail, Jupiter actually radiates more heat than it receives from the sun. That makes Jupiter a heat source. And that heat source is not coming from hydrogen fusion. That heat source is actually coming from the contraction of the planets. Yes, Jupiter shrinks to make heat, and the shrink rate is 2 centimeters every year. So Jupiter is shrinking, but over time we are not going to see a lot of difference in the size. Galileo was the first astronomer to look at Jupiter using a telescope, and he discovered 4 moons around Jupiter. Those are Io, Europa, Ganymede, and Callisto. Ganymede is the largest moon of the solar system, and if anybody is living on Europa, they are definitely not called Europeans. So those moons, the 4 moons, are known as Galilean moons, and this discovery changed the world, because by that time the current belief was the Earth was at the center of the solar system, and including the sun, everything else in the sky revolved around Earth. So when the discovery started saying that we discovered actually another bodies revolving around another planet, so that started making the astronomers questioning the knowledge of the solar system. Jupiter has 79 moons, and probably more depending on what we call moon, because Jupiter also has a very tiny dust particles orbiting around the planet as well. Well, all the giant planets are known as the vacuum cleaners of the solar system, because they do vacuum clean the solar system. All the debris and dust and all the small particles are pulled by the gravity of the giant planets, and they are either contributed to the body of the planet, which means fall on the planets as a debris, or maybe it may be captured by the planet and starts revolving around planet and becomes a moon. So for that reason, the giant planets, Jovian planets, are the vacuum cleaners of the solar system. If they didn't exist, if we didn't have Jovian planets in our solar system, the small planets like Earth would encounter more of meteor strikes. So they are keeping us safe, remember. Among those moons, I think the Europa is the most interesting moon around Jupiter, because it has icy surface. And what we think is below the ice, like the lakes froze on Earth, and the liquid remains as a liquid water underneath of the icy crust. And the same as Europa, and under the icy crust we think there's a liquid water, and the temperature may be enough and may be favorable for the conditions of life. And certainly this fact makes it a very interesting planet, and for this reason space agencies are trying to explore with more robotic missions, and the European Space Agency has a planned mission in 2022. It's called JUICE, stands for Jupiter Icy Moon Explorer, and the NASA also has a planned mission. It's called Europa Clipper. It is set to launch in 2023. So after those news, let's continue with Saturn. By the way, if you have any question, you can drop it in the comments chat, and I will try to answer it as soon as I can. One of the questions I can see, when gas giant is mentioned, what keeps gas compressed? Well, it's the gravity force of the planet. So similar to stars, the planets have gravity force, and the origin of the gravity force, we imagine it as at the center, pulling everything on the surface of the planet downwards, just like Earth is pulling us downwards on its crust. So that's what keeping the planet, the gaseous, even gaseous planet, in shape. And if we think about Earth, our atmosphere is also a gas, and it also remains in a shape because of the gravity is pulling down. So, great questions, thank you. Saturn, we are already there. I can't believe that. So this is the most beautiful planet. Now, how we define beauty. In this case, I usually take my reference as the sky watchers looking at Saturn for the first time. When we point our telescopes at the star parties, usually they say, no, it cannot be Saturn, it is fake, it is a picture. It is an artist drawn picture. No, it's not. Because the ring system is remarkable, and it is visible to any size of telescope on Earth. If you own one, take a look at Saturn next time. It is a great planet. So it is the second largest planet of the solar system. Its radius is about 9 times of Earth, but it is about 95 times more massive than Earth. One day on Saturn is determined to be very similar to Jupiter. It is 10 hours and 30 minutes, so it rotates fast. And what in the rings is very small particles of dust, rock, and ice. Mostly ice. And ice is reflective. That's why we see the rings very bright, because they are reflecting sunlight. And if you look at the back side of Saturn, there's a shadow casting on the rings. So that's a great view. We can see it with the telescopes as well. Saturn has at least 82 moons. The largest moon of Saturn is Titan. That is the second largest moon in the solar system. And even the Titan is even larger than Mercury. And the Titan is most interesting moon because it has atmosphere. I will come back to that point, but there is a question, why there's a ring around Saturn? Well, giant planets tend to have rings. Even Jupiter and other planets that we will be talking have ring systems. We don't see those rings because they are tiny, they are not very reflective. So we did not know Jupiter and other planets had rings, other Jovian planets had rings, until we launched space missions, because only space missions, the Voyager spacecraft took pictures of these tiny rings. Jupiter has a great ring system that is visible from entire world. So why rings? Because it is actually coming from the gravity and how gravity acts on the debris around the planet. So from celestial mechanics, the giant planet's gravity collects all the debris and gather them around an equatorial region, and that debris particles start orbiting around planets. It's very difficult to explain mathematically, even by scientists, the mechanics of the ring system. But we all know the small planets do not have ring system because they don't have enough gravity. But the big planets do have ring systems. We were talking about Titan, and what about Titan? It has the only moon in the solar system that has atmosphere. So that discovery was exciting when the Voyager spacecraft in 1980s flew by Titan and detected that nitrogen-rich atmosphere. The nitrogen-rich atmosphere created even more excitement because our air is also nitrogen-rich, if we look at it. And also Voyager detected some lakes on the surface of Titan too. Well, it sounds like we found just another world in the solar system. Actually, no, because those lakes and all the clouds we see on Titan are methane rich. So methane is a poisonous and highly flammable gas. Like it's like natural gas. And after the verification of all the methanes, the lakes are methane and the clouds are methane rich, and also there are methane showers, rain on the surface of this moon, which is making the life conditions miserable. And in 2013, the Cassini Spacecraft flew by to Titan. It also had a probe just disintegrated and released a probe, and that probe landed on actually the surface of this moon. It detected propene, which is also a flammable gas. So interesting thing is, we don't know why this moon is loaded with all the explosives. So in my opinion, the next spacecraft to Titan should not carry a lighter. Cassini mission was the most popular space mission around Saturn. The Cassini-Huygens spacecraft entered. It's actually not Huygens. It's the Dutch pronunciation is a little bit more different. There's no way I can do the correct pronunciation, but it's similar to Huygens. So Cassini-Huygens spacecraft entered into an orbit around Saturn in July 2004, and in December it released that the probe I mentioned, and the probe landed on Titan. In 2006, Cassini started tracking Saturn's sixth largest moon, Enceladus, and found liquid water reservoir beneath the surface, not from the moon's crust. Cassini also spotted over 100 geysers in the South Pole region of the moon, and these geyser jets are the ice particles that jets the water particles into the orbit of Saturn. So in 2011, because of the discovery of the underneath close to surface water and some heating mechanisms and the geysers, in 2011 NASA scientists identified Enceladus as the most emerging habitable place in the solar system after Earth. So if we look for life in the solar system, our primary focus point will be Enceladus, the moon of Saturn. So we are pretty much done with Saturn, and let's take a look at the some of the questions. Why does it have several moons? Well, some planets have more than one moon. Earth is the only planet that has one moon. Some planet doesn't have, but when we expect from the bigger planets to have more moons because of their vacuum cleaner effect. So they pull all the debris and all the smaller pieces onto them, and some of the debris will be captured and put on the orbit. So this is the factor of the result of gravity. More gravity pulls more objects. I see some of the links are posted in the comments chat. Do not click on them because they are going to ask some credit card information, login information that is not related to us. We don't collect credit card information. We don't collect any personal or credential information. What is the effect of these several moons? Like on Earth, it affects our water. Well, the effects of the moons on the gas giant planets are not very much to the planet itself, but the main effect of planets are usually they are keeping the planet's interiors warm. Like our Earth wouldn't have that much volcanic activity if we didn't have moon, and similar to Mars. Because like for example, Io is the closest Galilean moon to the Jupiter. Io is not doing a lot of things to Jupiter, but Jupiter is doing a lot to Io because it is keeping the interior, the magma of Io very active and melted. So that keeps the volcanic activity on the moon is going. So it is pretty much reverse. Let's go to the next planets. So Jupiter is the largest planet, the Saturn is the second largest, and which one is the third largest? Uranus is the third largest planet. So there's a nice order in that part of solar system. And Uranus is the third largest planet. The chemical composition of Neptune and Uranus is different than Jupiter and Saturn. So for that reason, some of the scientists like calling these planets ice giants rather than gas giants. The unique thing about Uranus is the rotation axis is tipped over 90 degrees, so it looks like rotating sideways. When we compare them with other planets' rotation, it seems like it rolls on its orbit like a wheel. And you can see the moon's tiny ring and the moons are representing the equatorial region, and how the axis is tipped on its side. Usually we would like to mention the correct pronunciation of Uranus because it's taken to some other ways. It's coming from the ancient Greek language, and the correct pronunciation is either Uranus or Uranus. So it is visible to naked eye where dark sky conditions exist. However, it was thought to be a dim star until 1781, as it moves slowly on its orbit. So when a planet is moving slowly in its orbit, it is not possible to detect its shifts respect to the background stars. So it was thought to be a star, and it was even catalogued as a star. So in 1781, Sir William Herschel, who is an astronomer, observed Uranus from his garden, and first reported as a comet because he decided a slight position movement. So he first thought to be it's a comet, and with the further observations he concluded that it was a new planet. So after his discovery, he received a compensation from King George, and he was given the right to name the new planet. By the way, the compensation he receives is approximately 24,000 pounds of today. That was a different amount that day. And because of the compensation, I guess, he decided to name the planet after his new boss and gave the name George. So for a while, when somebody spoke about the planets of the solar system, it was Mercury, Venus, Earth, then Mars, Jupiter, Saturn, and George. Well, the George was not recognized well outside of the Britain, and years later, new names were proposed by astronomers, and finally it was named as Uranus, also coming from Greek mythology. Can you tell me what's beyond Uranus? Yes, I can hear you. It's Neptune. So let's go to Neptune and find out what is interesting about this planet. So to me, Neptune's discovery is more interesting than the planet itself, because after Uranus's discovery, by Sir William Herschel, the Uranus was observed by astronomers to determine its orbit precisely. So they, for many decades, they kept taking the position measurements from Uranus, but they realized something was strange because Uranus was initially faster on its orbit. The faster in reference to the Newton's law. And then the planet started slowing down, put on brakes, and slowed down even further than how it's supposed to be by Newton's law. So that can be explained by two things. First, we can think, well, Newton's law is not working, or Uranus didn't want to obey Newton, which is fine. But another possible scenario is there may be some other planet beyond Uranus that is putting a tug force on the planet. So the second theory made sense, and immediately that triggered mathematicians to start working on some calculations and estimations, because if there is a planet that can create such amount of tug force, they thought they could estimate the size and the position of the new planet, and they were right. Immediately after, with some of the observations, the Neptune was discovered, and after this discovery, immediately the astronomers around the world started observing the position of Neptune to see if there is such a tug force on Neptune as well. It turns out, yes, Neptune also had a tug force. And they immediately named the planet that was going to be found after Neptune as Planet X. You may remember this Planet X from, I think it was almost a decade ago. There was a hoax going on, the Planet X appearing in the sky and in the collision course with Earth, and which didn't happen, which we said it was not going to happen because Planet X is not that Planet X. So, in effort to search the Planet X never be found, but what we found beyond Neptune is a whole different world of asteroids, or another asteroid belt which is greater in size and greater in the variety, and these led us to discover another asteroid belt kind system in the solar system, which we call Kuiper belt. We are going to talk about that next week. Is there ice or just gas? It's both. There are some gases. Especially I'm talking about the Uranus and Neptune. And there is another reason they are called ice giants. Some of the elements are in the ice form. When I talk about ice, I'm not talking about water ice. So ice is the form of a matter, a solid form of matter. So when we look at the interior of a planet, for example, this is for Neptune, it is the interiors. There is a solid core, we think there is. It's a very solid core, like Earth even has that solid core that creates the magnetic field. And on the outside, there are variety of gases, and those gases are different. For example, for Jupiter and Saturn, they are mainly hydrogen and helium, very simple elements. The elements are more complex for Uranus and Neptune. And another question I see, that gases give the blue color. So some of the gases are reflecting blue more than other colors, so that's why we see these planets blue. Can you tell us about Planet X? I cannot talk about something that is not existing, because the Planet X is a calculated planet based on the tug force of Neptune. So because the tug force on Uranus led to the discovery of Neptune, we thought that the tug force on Neptune can lead to finding another planet out there. But it turned out there is no bigger planet out there. The Neptune is with the current knowledge, the last of them, and we did not see Planet X. However, what we've seen on the other side, on the solar system, beyond Neptune, is smaller planets, icy planets, that are forming a giant belt. I am going to talk about next week because I'm already ate up all the time I have for today. And no, I did not forget about Pluto. So beyond Neptune, the Pluto is also considered part of this belt system, and I will explain why. And this is also related to the Pluto's planet status. So let's talk about more. And one more thing I would like to mention, Voyager 2 is the only spacecraft to visit Uranus and Neptune, and that was very old spacecraft that was launched in 1980s. So why there are no space, the modern space missions, Uranus and Neptune? All I can say is we are not there yet, because our modern spacecrafts just explore Jupiter and Saturn, and hopefully with some of the future space missions they will get to visit Uranus and Neptune as well. Well, I hope you enjoy our live streams. I am going to be here with my all crew next week, Tuesday 1 p.m. at the same time, and we will talk about Pluto and beyond. And thank you very much for listening. And I also would like to thank to my peers here, Jim Bader, Huzaira, and Jennifer, all the moderating the comments chat and of the Facebook. So hope to see you next week. Bye bye.